So now we've got this function. This is a quadratic. You recognize it? It's quadratic. It's a parabola. Leading coefficient is positive, so this is a parabola that opens upward. So I think we're expecting one minimum, and that's it. So let's see what we can do here. We're going to first of all start by finding the derivative, which is going to be 2x plus 10. And now let's get the critical values. So get the critical values. So we'll ask our questions. Number one, where is f prime of x equal to 0? So we're going to have that x squared, no, we're not going to, we're going to have our derivative 2x plus 10 equals 0. So 2x is negative 10, x is negative 5. So we've got a critical value here at x equals negative 5. And the second question, where is the derivative undefined? Nowhere, right? Undefined nowhere, because this is a polynomial function. Polynomial functions are smooth, continuous curves that are always defined. So let's make our sign chart here. I'm going to rewrite f prime of x right up at the top here so I have it easily. 2x plus 10, and I'm even going to factor. I can factor 2 out of there, getting x plus 5. All right, so let's draw our line, put our critical value in. There's only one critical value. That's here at negative 5. And let's analyze f prime. So to the left of negative 5, now we're to the left of negative 5, so we're in this interval right here. Pick a number, a test number like negative 6. Put it back in here. We've got a positive. Now if I put negative 6 in here, I get negative 6 plus 5 is negative. So what we've got here is a positive for the 2 and a negative for the x plus 5 term, right? If I put negative 6 in here, negative 6 plus 5 is negative 1. So I get a positive and I get a negative. I multiply those together. That gives me a negative, which implies the function is decreasing. So I know on this side here the function is decreasing. Now what about on this side? On the right side, from negative 5 on to infinity, pick a test point, like 6, and put it into our derivative. All right, so 2 is positive. That always will be positive. And if I pick 6 and put 6 in here, 6 plus 5, well, that's positive. Doesn't matter what number it is, it's positive. You multiply 2 positives together, you get a positive result, and that tells us it's increasing. So over here, the function's increasing. So by the first derivative test, we have a function that is decreasing on the left, increasing on the right. So our point, x equals negative 5, that must produce, right, that produces a relative minimum. And then to actually get the minimum, let's put that negative 5 back into the original function. So here's f of negative 5. I'm going to put it back in here to the original function to see what the corresponding y value is. So this will give us negative 5 squared plus 10 times negative 5. So we're looking at 25 minus 50. We're looking here at negative 25. So the relative min occurs at negative 5 for x and negative 25 for y.